For this video, we are going to be looking at a question from the Maths Core Paper 3 from 2020. Here's the question. So it starts out with some questions about this angle that they've given us a picture of here. And then it moves on to one of these triangles inside a circle question, which this one's fairly straightforward. Some of them can get a little bit intimidating. So what we're going to do is we're going to go through the entire problem step by step, and then we will check the answers ourselves against the mark scheme to see how well we did on this question. Alright, so first of all, looking at the question, the first part asks us, write down the mathematical name for this type of angle. Before we get too far into this, I just want you guys to consider if we have a 90-degree angle, it's going to look something like this. So this would be a 90-degree angle. And if it were a straight line, we would just have a line coming off of it like that. Alright, so this would be 90 degrees, and this would be 180 degrees. So right off the bat, we can see that this is not a 90-degree or right angle. We also know that obviously it's not a straight line or 180 degrees. That's definitely not what it is. And then also, because this line falls between 90 and 180, we know it's not an acute angle. Alright, so that only leaves us with one more option, which is obtuse. That means it's greater than 90, but it's less than 180. Alright, so that's how we do the first one. That's a very long explanation for a simple question. You should always, when you're doing these, look at the number of points each question is worth, because that kind of tells you how much time you should spend thinking about it. Alright, so I'm going to erase my pencil marks here. Alright, the next question says measure this angle. So normally what you would do is you would line up your protractor, something like this, and then you would look at the number where this line crosses, and then you'd write that down here. Alternatively, you could line up your protractor this way, right? And then you measure where it crosses over here. And again, you write the number down. Now, it's very hard to find any software that allows for virtual protractors. So what I've done is I've used a website to construct this angle so I can show you a better example of how you would do this. So remember what I just showed you. And then we're going to take a look at this website. This is mathspad.co.uk. And the file is at /i2/construct.php. So I've built this angle in preparation for this video, and I'm going to show you how you would use a protractor to measure this. So I've turned on the protractor. What you would do is you put the center of the protractor where the vertex is. And my protractor is a little bit too big. I'm going to change the size here. Make it a little bit easier. Obviously, you can't do that in real life. And then we're going to rotate it, and I'm going to line it up with this kind of bottom leg here until the zero line, right? You see this zero line right here? I'm going to line that up with the leg as closely as possible. So right about there. And then I'm going to look up here to see what number it falls on. And so what you can see is where this little hand is. If we count over, this is 130. So we go over 1, 2, 3, 4. So that means the angle is 134 degrees. So that's what we would write down. Alternatively, you could line your protractor up with the center, and instead of lining it up with this leg, you could line it up with this leg right here. So I'm going to show you that, because that'll show we get the same angle. So I'm bringing this down, and I'm going to line this line here, the 0, up with this one. Alright, so we've got our 0 on this side right about there. Oh, that looks good. See, our 0 is lined up along this. And then we go over here, and we're looking at this 0, so we look at the numbers along the outer edge. So we go 0, 10, 20, 30. We get up to 90, keep going, and then we're at 130 right here. Count over these little notches, so 130, 131, 132, 133, 134. So we've actually measured it from both sides. We got the same number, so that means that our answer is probably correct. All right, so I'm going to go back to the paper, and I'm just going to write down 134 degrees. Write down the mathematical name for an 8-sided polygon. So 8, think about an octopus. That's going to be an octagon. I can't really go into too much detail on this question because it's literally just memorizing the name of different shapes. Alright, work out the size of an interior angle of a regular 24-sided polygon. Now, these questions I am not a huge fan of because it's actually asking you, have you memorized an equation to figure this out? So in our case, yes, we have memorized equations to figure this out. Now, this is asking about the size of an interior angle. So that means if we have this shape with a bunch of sides, 24 sides, they're just asking about how big is one of these angles going to be, not the sum of the interior angles. So the equation that you should have memorized for this is each angle is going to be equal to n minus 2 times 180 and then divided by n. N is the number of sides. This is why I don't really like these sort of questions, because if you were doing this in the real world and you forgot the equation, you would just type it into Google, like equation for the interior angles of a polygon, and you would get some result that gives you this. But in this case, we're expected to have this memorized for the exam. So all we're going to do here is we're going to plug the number 24 in. So we're going to have 24 minus 2 times 180 divided by 24. And then rather than calculating that out, I would just throw it all into my calculator. I would do, in parentheses, 22 times 180, close the parentheses, divide by 24. So what I'm saying here is we would have 22 times 180 divided by 24. This is what we would put in our calculator. And then I would hit enter, and that is equal to 165. So up here, I would write 165 degrees. All right, so I'm going to just write off to the side these two equations that you should you should really just memorize in case you get one of these questions. So first we've got the sum of interior angles. So this would be if we added all of these up. So sum of the interior angles. The equation for that is n minus 2, n being the number of sides, times 180. And I'll write this one out. Each angle, this only works for regular polygons, each angle of a regular, I'm going to run out of space here, regular polygon. Right, this only works for regular polygons because that means all the angles are the same. So we can divide them up between each vertex. That is what I wrote over here again. N minus 2 times 180, and then you just divide that by the number of sides. So you should notice a pattern here. Right, this top part, the n minus 2 times 180, that's basically the total number of degrees in the shape. Why won't this let me do this again? I'm trying to change the colors here for you. N minus 2 over 180. That's the same as this. So really what you can do is if you can memorize just the sum of the interior angles, and then remember that ultimately to get the size of each angle, you just divide by the number of sides in the shape, then really you just memorize this. That'll give you the sum, and then if there's a question asking you for the size of each angle, then you just divide by the number of sides. But those are the two equations that you need to know in order to solve these. All right, let's move on to the next one. All right, so you will, almost always see these on an exam. There will be some triangles, maybe some tangents also. So maybe some tangents, and there will be a bunch of angles and variables and everything. And it's basically there to scare you. As you can see, the points for this question are slightly higher than before. We've got 3 points and 2 points, and then we have this one, which is 1. I just drew a tangent for you, so you can see why this one's only 1. But don't let these intimidate you. They are usually seen if you can remember some of the rules about where we have triangles drawn inside a circle, where generally the triangles will be connected to the center, and then you'll have points on the edges that kind of build up the triangles. All right, so let's just talk about some theory here. So for this one, we've got a vertex at the center of the circle, and then we've got one at A and one at B. All right, so this is one test. This is them testing to see if you understand one rule, where you have the points laid out like this. Now, the other one is where we have one side of the triangle. Sorry, I'm using the wrong color here. Wrong pen. Where you've got one side of the triangle is the entire diameter of the circle. And then you have one point on the circle, and when you connect that, it makes these two sides here, this one and this one. Alright, so before I go into any more detail on this, I'll tell you what the two rules are in a second. But really what you should do is you should just go to your web browser, go to Google, and then just type in, I don't know, triangles inside circles, theorems, or rules, whatever. Hit enter. And then if you go to images, sorry, this isn't Thai for some reason. Thanks for that, Google. Go to the images and you'll see there's all these different rules for all sorts of things. That's basically what they're testing you on. In this case, the question is using two of the simpler ones. So I'll go through this. So we've got the green rule, I'm going to call it, and the red rule. Alright, for the first question they say find the value of x, so they want us to find this. So that means we're going to be looking at this red triangle. So the rule here is if you have a vertex of the triangle at the center of a circle, and then you have 2 points on the circumference of the circle, then you're going to get an isosceles triangle. So this right here is going to be an isosceles triangle. What that means is we have two sides the same length and then one different, and then it also means we have two angles, so this one here and this one will be the same. So in this case, if this angle is 24, that means this one here also must be 24. So use this idea. You can fill out the triangle if you want. This is 24 degrees. So then to figure out what x is, then we're going to have x is going to be equal to 180 minus, and we've got two 24s. So I'm going to write it as minus 2 times 24. All right, so you can do that math by hand. You can do it in your head, or you can throw it in your calculator. It doesn't really matter what. I would probably do it two ways. If you want to do it in your head, then do it by hand to check. Even better, throw it into your calculator to be super short, as long as your typing skills are good in your calculator. So if we do this, we've got, this is going to be equal to 180 minus 2 times 24, so that's going to be 48. 180 minus 48 is going to be, let's see here, 180 minus 40 is 40 minus 8, 132. That's a 3, not a 2. 132 degrees. Throw that in your calculator, double check. Do that right now. 180 minus 2 times 24. Yeah, 132, so that's correct. So I'm going to write down, it is 132 degrees. And then for my reason, right, they put these dots here and it's 3 points. So I'm figuring this is probably 1 point, and then maybe the reason is 2. 1 point, I don't know. 2 points. So I would say the reason is it's an isosceles triangle. It's part of an isosceles triangle. I can't fit that in here, so I don't know how this is going to be 2 points. It's part of an isosceles triangle, and 180 minus 2 times 24 equals 132. I don't know, hopefully that covers all my bases. We'll see when we look at the mark scheme. Next one, find the value of y, give a reason for your answer. So in this case, we're trying to find y right here. This is using a different rule, and that rule is if you have a triangle where one side is the diameter of the circle, right? So you've got 2 points on opposite sides of the center being here. So these are on opposite sides. That whole side is the diameter. And then we have another point here, and these two sides connect to it. What this rule tells us is this angle right here will always be 90 degrees. If we move this point out here, we'll get a new triangle that also has a 90-degree angle at this point. So in this case, we know that this angle here is 73 degrees. This is 90. So again, what we're going to do is we're just going to do our math. So we're going to do 180 minus 90, right? So that's going to give us 90 degrees minus 73. All right, so that's going to be 90 minus 73. So that means we've got a 17-degree angle there, right? So if you want to, throw it into your calculator to double check. 180 minus 90 minus 73 is 17 degrees. So I'm going to write down 17 degrees here. Checked this in my calculator. Because I would say the angle at D must be 90 degrees because what is this? I can't even see now. EC, because EC is the radius, sorry, not the radius, the diameter of the circle, and 180 minus 90 minus 73 is equal to 17 degrees. This is how I would answer it. It's probably way too much information because they don't give you much space. We'll see what they're actually looking for on that mark scheme later. All right, last question, almost done. Draw a tangent to the circle at A. So this is our point A right here. I'm going to use a different color for this. So a tangent is just a line that goes kind of, if you were to draw a line coming out, so from the center of the circle here, and you draw your line out to A, the tangent is going to be perpendicular to this dashed line that I made. So what that means is I'm going to grab my ruler here, and I'm going to try and get it as close to 90 degrees with this as I can. Again, you can do this much easier with a real ruler, but then you wouldn't be able to see it. All right, that looks kind of good enough. See, I'm looking right here to see if this is going to give me a 90-degree angle. I think it will. Hopefully it'll be close enough. Here's my tangent at A. Hide the ruler, let's double check this. So what I'm saying is this line here should be perpendicular to this dotted line right here that's connecting A to the center of the circle. And that looks pretty good. So we've drawn our line. Hopefully that's okay. And we're done with this question. So normally, without all of this explanation, obviously you should be able to do it a bit faster. But let's go ahead and check our answers on the key. All right, let's pull the key over here a bit so I don't have to keep scrolling over. All right, so 3AI is obtuse. That's correct. Our angle is 134. Our octagon, yeah, good. Our math here, 165 for 1 point. So we got 1 point for 165. And then 360 over 24, or 24 minus 2 over 180. We've got that right here. So we got our 2 points for that one. Bring this down again. Um, 132. So for angle OBA equals, so this one, let's see, how are these points divided up? I see, so we get 1 point for this, 132 degrees, that's 1 point. It's part of an isosceles triangle, that's our second point. And our third point, OBA, so that would be OBA, so that would be this one saying OBA is 24, which we've kind of implied in our work here. So I'm going to go ahead and give myself that third point. All right, next one. So we got 1 point for 17 degrees, and we got an angle in a semicircle is 90 degrees. The angle at D must be 90 degrees. Yeah, I guess that kind of counts, the angle in a semicircle. That's a little bit iffy. So I don't know. Yeah, I'm going to give myself the point. I think any reasonable grading person would give you the point for that. All right, ruled tangent drawn at A. So this is actually pretty key. Ruled, this means don't sketch it by hand, right? Don't just try and kind of do a scribbly straight line like this, right? So you need to use your ruler. We did that. So we got 1 point here. So if we go through this, then it looks like we have gotten 100% on this question. The only possibility where we might have lost a point is right here. But again, I think any reasonable grader would give you the point for knowing that rule. All right, so I'll zoom out here and I'll leave you with notes for a couple of seconds. Get it all to fit. Yeah, good enough. I suppose I can zoom in a bit, can't I? All right, so there are the notes and the mark scheme. If you need to, pause the video to go over those. But hopefully that will help you if you run into any of these angle, or specifically these what I consider somewhat evil circle and somewhat evil memorizing equations that you would normally just look up if you can't remember in real life. That's it. Thank you.